Time travel. The very phrase ignites our imaginations, sparking dreams of journeys beyond the constraints of the present. It whispers of adventures across millennia, of witnessing history firsthand, of perhaps even altering the course of events. Imagine standing beside great leaders or experiencing pivotal moments that shaped our world. But is time travel merely the stuff of science fiction, or could it one day become a reality? Could our wildest dreams of traversing time actually come true? From the pages of H.G. Wells' The Time Machine to the silver screen voyages of Back to the Future, time travel has captivated audiences for generations. These stories have become cultural touchstones, inspiring countless other works. These stories, while fantastical, often tap into a deep-seated human desire, the yearning to revisit the past or catch a glimpse of the future. They reflect our hopes, regrets, and endless curiosity. Early literary explorations of time travel often involved magical artifacts or unexplained phenomena, weaving tales of wonder and mystery. However, as science advanced, so too did the narratives surrounding time travel. Writers began to explore more scientific explanations and theories. Modern science fiction often incorporates concepts from physics, such as wormholes and time dilation, lending a veneer of plausibility to these temporal escapades. These scientific elements make the stories even more intriguing. While these fictional accounts serve as entertaining thought experiments, they also invite us to ponder the scientific possibility of time travel. Could the future hold the key to unlocking the secrets of time itself? To comprehend the scientific perspective on time travel, we must first grapple with the nature of time itself. Physics tells us that time is not absolute, as our everyday experience might suggest. Rather, time is relative, its passage intertwined with motion and gravity. Einstein's theory of special relativity, put forth in 1905, revolutionized our understanding of time. This theory revealed that time slows down for objects in motion relative to a stationary observer. The faster an object moves, the slower time passes for it. This phenomenon, known as time dilation, has been experimentally verified. Einstein's groundbreaking theory of general relativity, published in 1915, provided further fodder for time travel enthusiasts and revolutionized our understanding of the universe. This theory describes gravity not as a force, but as a curvature of spacetime, the very fabric of the cosmos, which can be visualized as a flexible sheet. Massive objects like stars and planets warp spacetime, much like a bowling ball placed on a trampoline stretches the fabric, creating a dip around it. General relativity allows for the theoretical existence of wormholes, which are tunnels that connect distant points in spacetime, potentially offering shortcuts across the universe. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps us visualize how a wormhole might connect two separate points. A wormhole, in theory, would act as a shortcut through the fabric of spacetime, potentially allowing for travel across vast distances or even through time itself, bypassing the conventional limitations of space travel. Another intriguing concept born from general relativity is the warp drive, a hypothetical propulsion system that has captured the imagination of scientists and science fiction writers alike. This hypothetical propulsion system would involve compressing space-time in front of a spacecraft and expanding it behind, effectively allowing the spacecraft to ride a wave through space-time at speeds exceeding the speed of light, making interstellar travel a tantalizing possibility. While theoretically permissible within the framework of general relativity, warp drives remain firmly in the realm of speculation, as we have yet to discover the means to create or sustain such a phenomenon. While wormholes and warp drives remain purely hypothetical, time dilation offers a tantalizing, albeit limited, form of time travel to the future. As previously mentioned, time slows down for objects in motion relative to a stationary observer. This means that if you were to board a spacecraft and travel at a significant fraction of the speed of light, time would pass more slowly for you than for those you left behind on Earth. Upon your return to Earth, you would have aged less than your counterparts, effectively having traveled into the future. The faster you travel and the longer you travel for, the more pronounced this time dilation effect becomes. Section 5. The Grandfather Paradox and Other Temporal Nightmares. The prospect of time travel, particularly travel to the past, raises a host of logical and philosophical conundrums. Perhaps the most famous of these is the Grandfather Paradox. Imagine traveling back in time and accidentally killing your grandfather before your parent was born. This act would seemingly prevent your own existence, creating a paradox. If you were never born, how could you have traveled back in time to kill your grandfather in the first place? The grandfather paradox highlights the potential for temporal paradoxes if one could alter the past. Physicists and philosophers have proposed various solutions to this paradox, including the notion of parallel universes or self-consistent timelines, where any changes made to the past simply create a new, branching timeline. Section 6. Quantum entanglement, a bridge to the past. Quantum entanglement, a bizarre phenomenon in which two particles become linked and share the same fate, even when separated by vast distances, has also fueled speculation about time travel. Some physicists have theorized that entanglement could potentially be exploited to send information back in time. However, these ideas remain highly speculative, and it's unclear if quantum entanglement could truly facilitate time travel. Section 7. The ethics of tampering with time. Beyond the scientific hurdles, time travel, if achievable, would present profound ethical dilemmas. The ability to alter the past or influence the future carries immense responsibility. Even seemingly insignificant changes to the past could have unforeseen and potentially catastrophic consequences for the future. The ethical implications of time travel would necessitate careful consideration and regulation to prevent misuse of this technology, should it ever become a reality. Section 8. Time travel, a distant dream or an eventual reality. So, is time travel merely the stuff of science fiction or a tantalizing possibility that awaits us in the future? From the pages of H.G. Wells to the silver screen adventures of Marty McFly, the concept of traveling through time has always fascinated us. While we have not yet unlocked the secrets of time travel, the pursuit of this knowledge continues to captivate our imaginations and drive scientific inquiry. Researchers and theorists alike ponder the paradoxes and possibilities, pushing the boundaries of what we know. While the laws of physics as we currently understand them do not explicitly forbid time travel, the technological hurdles remain formidable. Concepts like wormholes and the bending of space-time are tantalizing, yet remain largely theoretical. Perhaps one day, armed with a deeper understanding of the cosmos, we will unlock the secrets of time and embark on journeys through this most enigmatic of dimensions. The universe holds many secrets, and time travel might just be one of them. Until then, the mysteries of time travel will continue to intrigue us, reminding us of the boundless possibilities that lie at the intersection of science and imagination. As we stand on the precipice of discovery, who knows what the future holds?